the size or shape of the image. It just moves it around in the plane. Specifically, it maps point P to point P prime such that the measure of angle PRP, remember that's point P and point P prime, that's the image in the, or the pre-image of the image, and R is the center, that angle will be X degrees. Okay, and the length of segment RP will be the same as length of segment RP prime. We always do it in the counterclockwise direction by default. So unless otherwise noted, the rotations are performed in a counterclockwise direction. And we use this because it's the same direction we label the quadrants in. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. We're labeling in the counterclockwise direction. Rotations can be of any degree, but you should be able to perform 90, 180, and 270 by hand, as well as be able to recognize estimates of other rotations. That's our expectation for you in this unit. Rotations can use any center of rotation, but we're going to focus primarily on using the origin as our center. We will occasionally do some others that don't use the origin, but the origin is our main goal here. So here you can see I have a pre-image, ABC, and it was rotated. Well, if I look, A goes to A prime, that's 90 degrees. Okay, if I were to draw the angle that connects those 2 points, that's a 90-degree angle. Okay, it was rotated 90 degrees in the counterclockwise direction. Around the origin to produce image A prime, B prime, C prime. Now, here's the fun part. Let's try to figure out what the rule is that governs this kind of rotation. If I have a point XY, what do the new coordinates become if we rotate it 90 degrees about the origin? Well, let's look at some examples. A is at 1, 4, and A prime is at -4, 1. B is at 3, 2, and B prime is at -2, 3. Well, what looks like is happening, my new X value here appears to be similar to the Y value, but it's the negation of the Y value. So I think this value here must be -Y. And my new Y value appears to be exactly the same as the beginning X value. So we think our law is -XY. Let's test it with point C to see if it works. So C is at 4, 4. Well, that's not a great point to test with, but oh well. So using this, I would expect it to become -4, 4. Did it? Yes, it did. All right. Let's look at another example. This is the pre-image EFGH. And let's see how far it was rotated. I want to pick a point and join it with the origin and its image to make an angle. That is a straight angle. So that means we rotated 180 degrees, still in the counterclockwise direction, around the origin to produce the image E prime, F prime, G prime, H prime. Now let's take a look at the points and see if we can figure out our law. So E is at 1, 1. E prime is at -1, -1. is at 0, 3. F prime is at 0, negative 3. G is at 3, 3. And G prime is at negative 3, negative 3. And H is at 3, 2. And H prime is at negative 3, negative 2. Well, looking at the changes, it looks like we're just multiplying each coordinate by negative 1. So my rule would be x comma y leads to negative x, negative y. All right, let's do another example. Now we're going to rotate the following figure 270 degrees. That means I need to produce the reflex angle 270 degrees using the origin as my point. So 270 degrees, well, if I were to go backwards, that would make a 90-degree angle. So we know we're going to have that kind of angle. So looking at this, K, to get to K, I went over 2, up 1. To do a 90-degree angle, we do the opposite reciprocal. Over 1, down 2. This right here is K prime. To get to L, I went up 1, over 4. A different color. I went up 1, over 4. So to do L prime, I'm going to go over 1, down 4. And M was over 4, up 3. I'm going to go over 3, down 4 for M prime. And N, over 2, up 4, over 4, down 2. J, over 1, up 3, over, let me get a different color, I'm out of colors, over 1, or sorry, over 3, down 1 for J. So when I connect these together, I get the same shape. It looks like the same shape. We just have rotated it 270 degrees. So the pre-image, J, K, L, N, M, was rotated 270 degrees in the counterclockwise direction around the origin to produce image J prime, K prime, L prime, N prime, M prime. Now let's look at the law. K is at 2, 1. K prime is at 1, negative 2. So looking at this, the x value of the image appears to be the same as the y value of the pre-image. So make that y. And the y value of the image appears to be the same, or appears to be the negation of the x value of the pre-image, negative x. Let's see if it works. I'm going to look at L now. L is at 4, 1. So I would expect it, if I flip it, I want 1, comma, negative 4 for L prime. Well, let's look. 1, comma, negative 4. It works. Good. All right, symmetry and rotation. Rotational symmetry exists when a figure is the image of itself after rotating through any angle between 0 and 60. So, for example here, a square has rotational symmetry of 90 degrees because if I rotate it 90 degrees around its center, then the A value and A prime, 90 degrees, we're going to end up with the exact same image. It's going to look exactly the same. We've just shifted it 90 degrees. So we say it has rotational symmetry. These quadrilaterals have the same rotational symmetry, side lengths, angle measurements when we rotate them. So we say that it has a rotational symmetry of 90 degrees, and we could keep turning the square to get the same image by turning it 180 degrees, 270 degrees, and 360 degrees. Therefore, we say this square has rotational symmetry of 90, 180, 270, and 360. The order of a figure with rotational symmetry is the number of positions in which the figure looks the same. So, for example, this square up here has an order of 4 because there are 4 different angles between 0 and 360 where it would map onto itself. Here, H, this shape has symmetry, 180 degree symmetry, and it has an order of 2 because I can only flip it twice and still make it look like itself. The hexagon here has, well, if we look, I could rotate it 6 times, so it has an order of 6, and it has rotational symmetry of 60 degrees. And we could continue that 120 degrees, 180, 240, ooh, hello, 300, and 360. The trapezoid here has no rotational symmetry. We cannot flip it any degree other than 360 to get it to map on itself. However, it does have an order of 1. Any shape that has no rotational symmetry still has an order of 1 because it will map onto itself at 360 degrees. Okay, point symmetry exists when a figure has a rotational symmetry of 180 included somewhere in it. So here, this triangle does not have point symmetry because it has symmetry at 120 degrees, 240 degrees, and 360 degrees, but it does not include 180. The square does have point symmetry because it has symmetries at 90, 180, 270, and 360. I want you now to figure out whether or not the hexagon has point symmetry at any degrees. Now, look at the letters below and determine if they have rotational symmetry, point symmetry, or neither. I want to see this in class tomorrow. So, on your own. Have a great day. Thank you all very much.